Hey there, welcome. So this is our final, I believe it is. Yeah, it's our final video in the Weapon Sway or the Weapon Bob video series. So if you haven't checked out the other ones, please feel free to. And um, here we're showing that the Weapon Sway is not hooked up. I've got it disconnected just really quick, just to show you this capsule stuff. So I turned on show the capsule and I put this arrow in there. And in one mode, when we're not strafing, if we're turning and looking our mouse around, we can see that the capsule is not rotating. But if we start strafing, we can see that the capsule is rotating. And then our character will have a turn in place animation to update that. What's really important here is not what the character is doing, is what the capsule is doing. That's why I wanted to show those two. So when we're moving and I push left and right, we can see that the capsule is rotating and then the character follows to go into the direction that we're moving. And then if we're strafing, we can see that if we push left and right, that the capsule stays facing the direction that it was. If we want to turn it, we need to incorporate mouse movement. Okay, so now that we understand that, what we are trying to do is just one thing here. Let me grab this out so I can show this here. I'm going to take this one and this one and this one. Okay. So I've got a get transform bone in our control rig. I've got the bone. I've got the bone name weapon sheath 02, and I'm just going to move it back a little bit. Whoops. Let's move these over here. So we're going to get our value, get our translation. We're going to move it back, and then we're going to hook up everything else: scale, rotation, X, Y, and translation. But we've got our -50 on X. So at some point when I was fooling around with all this weapon sheath stuff, I had the weapon really far back like that. And what I noticed was that when I am not strafing and I'm moving forward and then I press forward left or forward right, that how that snappiness that I feel in the weapon and the arrow that is shown, I didn't like that. I didn't like how when I push left forward or right forward, that we just the sword rotated with the camera and there wasn't like a lag or a delay or an overlap to kind of offset um, the rotation or the new position of the knight of the sword in relation to the position that it wants to be in with the capsule. So I wanted to figure out how to do that. One of the reasons why I abandoned this setup is because I usually don't have the weapon this far back. Um, so we just look at our final setup. It's all the way over here somewhere. So I recorded that in another video. That hasn't changed. So if we play here again, we can see that the weapon is pretty close to the character and there's a lot of bobbing around on the weapon. So like it's still doing that same sort of thing and snapping, but because there's so much extra motion there on the sword already, that that feeling just went away. So that's one of the reasons why I abandoned this setup. But I thought um, that it might be worthwhile to go through the setup to show you what I've got, and maybe you all out there can figure out how to use it in a better way than what I did, and then just completely abandon it. All right, let's go all the way back over here. So some of this setup or some of this information I had gotten from a tutorial series I did. Um, so I'll try to walk you through that. And here's the initial setup. We've got a two world node. That's basically getting our root since we're not calling a bone or anything. It's just like, hey, what's the character doing? And we're using this node called Delta from previous as a quaternion. And then you can spit that out as an Euler. and then you can get the specific axes that you want. So we want Z, and that's the yaw. So that's our left and right rotation. Um, so from here, if you just spit out just the Z from that, it's going to be the difference. So we play again. We're printing that out to our screen. So you'll see it here, and you'll see it. Whoops, you'll see it up here too in the top left corner. So like I said, our capsule isn't rotating here, but if we go to strafe, our capsule is rotating, and the numbers you see adjusting is just the difference from the previous location. So where we were, where we are, and that value, how much the value changed on tick essentially. So if you move really fast, it's higher, and if you move really slow, it's lower. You may also notice that if I look left, it's a negative value, and then if I look right, it's a positive value. And then here, we look here, we can see this value. So this value is basically spitting out that change here, and then we're adding that change to that same variable. So we're getting what we were, we're adding it, or we're getting the delta and we're adding it to what we were, and then we're making that to where we are. And then we keep adding it over and over again. So you'll never see this value come back down to zero unless we start turning in a negative direction. So we just keep adding it on top of itself. And then here we're now subtracting it from itself. So those are basically the two values that we'll use the most here. So how much did I rotate left or right from previous value? And then what's the accumulated value that you've rotated? Okay, so let's go to the next one. So the next thing that we'll do here is we'll use our delta to create essentially an alpha here. So because I don't really care about the negative part of our delta, meaning that if you turn left, it's negative, I just want to know, are you at zero or are you greater than zero? And if you are, which we're just getting the alpha here, I'm sorry, the absolute value. So basically it spits everything out as a positive number. So we get that delta and we spit it into this alpha interpolate. And this alpha interpolate has some different values here, and you can play around with those as you see fit. This is kind of like a map range here. So if you know your values coming in, you can spit out specific values coming out if you wanted to. Really, all I wanted to do was get an alpha, so 0 to 1. And then we spit that out. So whatever our value is here, we're going to just take that and then we're going to clamp it to a 0. So if we're 0, this will be 0. And if we're, say, the highest value, which is probably, I think that what I noticed was like a 12 or negative 12, or in this case, because it's absolute, it's always 12, then that essentially is going to be our 1. And then we're going to interpret that result. So basically, as we move to 1, and we increase from 0 to 1, it'll move much faster. So I've got a 10 value here, which is the default. And then as we move from 1 to 0, so we're decreasing in value, I've got a 0.2 here, and that will move much slower. So I think we can watch this maybe. Let's bring this over. Okay. So we're playing and nothing. Oh, here we go. This should help. Okay. So we're not getting any rotation here because we're in strafing mode. So we're slowly moving back down to 0, very, very, very slowly. And then if we get you out of strafing mode, we can see is like as I rotate, we go up to that 1 value, and then we very slowly move back down to 0. Okay. So the next thing that we do is that we use our yaw rotation to, I believe we're trying to get yaw back to zero. Our yaw amount that we've rotated here back to zero. So basically, I want to know is like if we're not turning, I need you to move back to zero. I don't want you to keep accumulating for forever. Whoops, I don't need to compile that. We come back here. So let's see here. We are not getting any value now. So hopefully, there we are. So basically, this is just a way to use the delta as a a way to take the value of our yaw rotation amount that we've changed, like whatever that is, and start to bring it down back to zero. So we can see that instead of that value accumulating forever and staying where it was at that accumulated amount, we're essentially ramping that back down to zero. So that's done through here. So we've got our alpha. We take our 1, 0 to 1. So if we're at 0, we want to move our yaw amount back to 0. If we're at 1, we're just like we're at whatever our yaw rotation was. And then like as we ramp that back down to 0, we'll update our yaw rotation. Our yaw rotation will become the new number. That'll be piped back into here. We're moving back down to 0. Then this one, it's kind of like the circle that just keeps moving. So our yaw rotation amount will decrease back down to 0, which is what we've been seeing. So we rotate and we're not rotating anymore, and then it goes back down to 0. We rotate, we're not rotating anymore, and it goes back down to 0. So that's great. The next thing that we're doing is we're just setting a new variable here, and we're just clamping our rotation to be negative 45 and 45. So basically, it's on our diagonals. Like we won't ever consider anything more than like a forward left 45 degree and a forward right 45 degree. And I'm showing you the end result right now, actually. So like you see how um, if I'm moving forward and then I hit right, now I'm moving forward right, that weapon slowly moves to its new position. And I hit forward left, that weapon slowly moves to its new position. One of the things I didn't like is that if you're hitting forward right and then hit forward left, it kind of snaps back to the old position and hangs out and kind of slows down in this dead man zone. Something I didn't figure out. Um, but I also, like I said, I abandoned this, so I just kind of gave up on it because I'm not using it. But at the very least, you can see how I did fix that initial thing that I wanted to fix, which was you're moving forward, you turn right, and the weapon lags behind and doesn't snap like the arrow snapping. Then you move left, and it lags behind again. So if we just get rid of that just for funsies again, so look, oops, this one here, so we can see the offset. So we can see how that weapon is snapping again. But with that change, we can see how it's kind of slowly moving. Okay, now that we've got that, so we've got all our variables, we've got our clamped variable that you're using, then what is the thing that is actually doing the work? And that's this guy right here. And this is the thing that I got from one of the videos, one of the tutorial videos I did. Um, this is a function that essentially takes the rotational value of what the change is and pipes that in to be a new location from where you were to where you should be, as I understand it. One of the ways that we use this in the tutorial was essentially a turn in place animation to rotate the foot around the root bone and keep that offset from the foot original location to the root bone location, and it just kind of rotates with it. Okay, so we've got our negative 50, negative 150 here, just so that we can show like the further away you are from your pivot location, then the more obvious the rotation difficulties are. So that's what that 150 is for. Um, okay, so then we're getting our clamped value for our yaw rotation, and it looks like I needed to negate that um, so that it does the opposite amount of rotation. So if I say if the character is facing this way and then rotates that way, so we've rotated left, so now we're facing this way, then the weapon is going to go this way too. But right away, I want to keep the weapon kind of where it was. So I need to rotate it exactly the opposite amount that we were rotating our character so that our weapon stays in the same spot. And then it slowly moves over here to the spot it needs to be in. So that's why it's a negative value here. So we're just um, taking the opposite amount of rotation and just counter rotating it essentially. So what is our rotation amount here? The amount that we're piping in is the opposite amount that we've rotated. Okay, so I think everything's pretty straightforward. The point to be rotated around, since that's the root, it's just 0, 0, 0. We're not piping anything into there. The point that you can rotate around could be like another bone. So, like if you wanted to, say, get another bone, it's the, let's say, the clavicle left, then you could get that there and then rotate it there. I'm not sure what this will do. It might be funny. Ha 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 ha, funny. So, anyway, so it does more or less the same thing, just slightly changes its location. Seems like about where it's rotating around. Um, okay, but because I wanted to rotate around the root of the character, the center of the character, um, I just left that as 0, 0, 0. Then the other things that we're piping in the rotation from our get transform node for our bone. So it's the same bone that we're using. So weapon sheath O2. So rotation is the same, scale is the same, X and Y and Z are all the same. And then the uh, the function pipes out essentially a transform that we can use. So I'm just using that transform wholly as it's calculated within the function. So let's go in the function. So the function is actually it's opening up another control rig because it's a function I set up in another control rig and then made it a. If you come over here, it's auto saving. Okay, rotate around point. So that's this function here. You click on it and say access specifier. You can either change it to public or private. And if it's public, then that becomes available to say your other control rigs. So if I want to say rotate around point, there it is. So I can call it. And then that's the function from the other control rig. And you can see from game characters, heroes, girl rig, CRF for control rig functions, and then rotation functions. Let's go back in there. So when you double click it, it just opens that control rig. So we've got our input transform that's broken out into translation, rotation, and scale. So we've got all that being piped in. Um, so this, I'm just going to tell you how it's set up. I don't really understand how it's set up. Um, so we've got our rotation in B of the multiplier being multiplied by our rotation amount in A. And then we spit that back out as our rotation in our new transform that we're creating. And then we have our point to rotate around. So since it's 0, we're adding, because we didn't actually pipe in anything into here, we're adding our rotated vector into B. So our point to rotate around is A. We're adding what is, it looks like our translation from our transform bone. And we're subtracting that from our point to rotate around. So that would be wherever you are minus the point to rotate around, which is 0 here. And the result is whatever whatever that value is as a vector. Um, so basically, it's probably just getting that offset. And then we're rotating that vector. So the rotation amount as the transform and the vector. Then we use this rotate vector as our B to add. And then our summation of all of that becomes our translation for our, I guess this should be hooked up to, for our transform. So we compile that. I don't think I have that up. So let's compile that because I made that change. Save, then play. Then, like I said, we can see our results there. So it's fine if I'm not switching from forward left to forward right because it kind of hits that snag in the middle, which is kind of what I was trying to avoid. Um, but it's got some promise, and I could potentially use this in another location. Um, but I think that's basically it for the video today. We've got a good screenshot of that rotate around point. We've got our control rig that we're using here for essentially setting our bone transform and just like slowing down that rotation by the like we're countering that rotation by the amount that we've rotated up to 45 degrees. So anything above 45 degrees, we wouldn't be countering anymore because we've clamped it. And here, get rid of those. We just overview it. We get our rotation delta from our previous location, our previous rotation, and from the world. Um, we spit out a rotation amount that keeps accumulating on itself. And then we spit out just the raw amount that we've changed. So that if we haven't changed, we know that we're no longer rotating. And if we have changed, we know that we are rotating. And if you really wanted to, like I said, a left rotation here is considered a negative value, and a right rotation here is considered a positive value. And then we use that delta to create an alpha, and we interp quickly into that alpha because our rotation speed is really, really fast. So I want to get to that rotation amount and counter that rotation as fast as possible, and then slowly move back into our original position, our position to where the sword should be. So we are we're slowly decreasing our interp speed. Our interp speed is really, really low, so that we're slowly moving from 1 to 0. And that allows us to reset our yaw rotation back to 0 because it knows whether or not we're rotating. And then we're clamping our yaw rotation to our negative 45 degrees. And you can probably clamp that however you see fit. And like if we were to say like negative 165 or 165 or something like that, then you'll see a slightly different result. So like you actually get a better result here when you're moving from like left to right, forward, left to right. That's actually good to know because I hadn't really tested that before. But I do know that like in strafing, like it kind of gets in this ugly spot where the weapon is in front, and then when the alpha starts bringing that rotation amount back to 0, it rotates around the point. So that's why it's not clipping the character. So it rotates around our character. So that's nice. But it gets into this ugly spot when we're strafing. So there's probably something I could do there to say that if we're, I mean, that's not good either. So there's probably a number there that fits it maybe a little bit better. Let's try 90 to 90. And that kind of gives it a like a 180 spectrum that might, yeah, that does fix that. So how far do we get here? So basically you can go on the left side of the character. What if we're rotating? So yeah, it can go as far as on totally on the left or far as totally on the right. So I don't know. That's just weird. I want the weapon to be like behind the character. So there's probably ways to like clamp that depending on like how much you're rotating and how fast you're rotating. Clamp that even lower. Um, so anyway, then we pipe that all into our rotate around point and then into our set transform bone. So hopefully that helps you. And that is the, like I said, the final video for the weapon sway. Um, all right, happy animating out there and enjoy the journey.